Hello everyone, welcome to Puzzle League and another tutorial episode of the Variety Sudoku Intermediate Series. My name's Eric, and today we'll be looking at the Kropki puzzle. As always, first we'll go over the rules together to make sure we understand the puzzle. Then we'll take a look at the workbook solving example, and finally I'll solve a complete problem from the beginning. Alright, let's get started. So the rules are just like those of classic Sudoku with a few additional rules. Now pay close attention because the rules are a bit more complex than the previous puzzles we've seen so far in this series. So the first rule is that white circles must be between numbers that differ by 1. This one is pretty self-explanatory. The second rule is that black circles must be between numbers that differ by a factor of 2. This means that for the two numbers that are around any given black circle, you should be able to multiply one of them by 2 to arrive at the other number. For instance, such pairs would be 1 and 2, or 2 and 4, or 3 and 6. Now the third rule is that cells without circles must neither contain numbers that differ by 1, nor numbers that differ by a factor of 2. So we have to make sure the numbers in cells without circles do not obey rules 1 and 2. If we look down here at this example, we'll see that in block 1, a black circle separates the 2 and the 4, which differ by a factor of 2, right? Because 4 is 2 times larger than 2, or conversely, 2 is 2 times smaller than 4. Also here, a white circle separates the 5 and 6, which differ in magnitude by 1. 5 plus 1 is 6, or equivalently, 6 minus 1 is 5. And lastly, the numbers 2 and 5, between them there is no circle. And this is correct, because 2 and 5 neither differ by 1 nor by a factor of 2. And that's why we don't want a circle between them. Over here, we can see that the pair of numbers 1 and 2 obey both rules. So you can put the numbers 1 and 2 around white circles and black circles, because 1 and 2, they differ by a magnitude of 1, and they differ by a factor of 2. Now I hope that's clear, but if it's still a bit confusing, don't worry, we'll be seeing lots of examples soon. Alright, let's go through this example together. If you're following along, go to page 115 of your Variety Sudoku Intermediate Workbook. I'll be explaining each of these 4 progressions. So in this first progression, let's see here, the 6 has a black circle to the left of it, which tells us that the cell must contain a number that is either 2 times larger or 2 times smaller than 6. But the thing is, we have a 6 by 6 puzzle, right? So the largest number that is available to us is 6, which means the cell adjacent to this black circle must contain a number that is 2 times smaller than 6. And that number is 3, and you can see that in red. Now the cells that are linked by a dotted line from A to B all have white circles between them. So we know that they must consecutively differ by 1. Now imagine these numbers were not here. We could have started with the number 1 in cell A and ended with the number 5 in cell B, but we didn't. Why? Because if we had placed a number 5 in cell B like this, a number 4 here, number 3 here, a number 2 here, and a number 1 here, although this follows the rule of the white circles, it would break rule number 3. Because the numbers 5 and 6 differ by 1, however, there is no white circle between them. So we have to put the numbers in this order, from 5 to 1. Now if we take a look at this second progression, the number 1 that we just placed in cell B must be next to a number that is twice as large. And that number has to be 2. Now this number 2 also has to be next to a number that is twice as large, which is 4. Finally, the last remaining number of this column is the number 5, which is why we can just fill it in here. Okay, let's move on to the third progression here. In this one, the 4 in block 1 has a black circle next to it, which tells us that this cell must contain a 2, the number that is twice as small as 4. Now, since the yellow cells have a black circle between them, we know that they must contain 3 and 6, which is the only remaining pair of numbers that differ by a factor of 2. However, the cell beside the 4 doesn't have a white circle here. So we know that the 6 must be placed beside the 4, as shown in blue. If the 3 and the 6 were swapped, let's say like this, well, this would be incorrect, because 3 is 1 less than 4, so there must be a white circle between them. But since there isn't, we cannot write it this way. And then using the same logic, we can complete the rest of the puzzle. Now, you might find that Kropki, due to having such constrained rules, isn't as difficult as it may seem, because the range of possible numbers that we can place in a given cell is actually quite restricted. Okay, with that in mind, I will be solving workbook example 121 from the beginning. Now, if you haven't done so already, I encourage you to pause the video and try it yourself first, and then come back if you get stuck or if you want to know how I solve these problems. Okay, so if I take a quick look at the puzzle, I notice that block 6 has one number filled in already, and it has quite a few black circles. So I know that since there are fewer number pairs that differ by a factor of 2 than those that differ by a factor of 1, black circles are more constraining than white circles. Now what I mean is, let's list out all the number pairs that differ by a factor of 2. So there is 1 and 2, there's 2 and 4, and there's 3 and 6. So there are only 3 pairs here, right? 3 pairs of numbers that differ by a factor of 2. Let's list out all the pairs that differ by a factor of 1. So there's 1 and 2, there's 2 and 3, there's 3 and 4, there's 4 and 5, and there's 5 and 6. So we can see here there are 5 pairs of numbers that differ by a factor of 1. So this is what I meant when I say that there are fewer number pairs that differ by a factor of 2 than those that differ by a magnitude of 1. Which means that black circles are more constraining than white circles. So black circles give us stronger hints as to which numbers can be placed where. So I went through all of this just to say that I want to start in block number 6. It has quite a few black circles, and it already has one of the 6 numbers filled in for me. Now, of course, you don't have to start in the 6th block, but I reasoned that it may be easier than starting in one of the center blocks, for instance. Okay, so let's take a look at the 6th block. The only number that is twice as small as 6 is 3. So this black circle, again, means that we must put a number in this cell that differs by 6 by a factor of 2. Obviously, the number 12 isn't available to us, so the only number that we can put here is 3. Now, around this black circle, we can place the numbers 1 and 2, or 2 and 4. Let's see what would happen if we placed 2 and 4 like this, keeping in mind the 4 in the 5th row. We're now left to place numbers 1 and 5, but they would be separated by a white cell, which would break rule number 1, saying numbers in white cells must differ by 1. So there is no possible way we can place the remaining numbers 1 and 5 in either configuration due to this white circle. So we know that the numbers 2 and 4 cannot be placed here. Now this tells us that this black circle must separate the numbers 1 and 2. Now, which number should be placed where? If we were to place the number 1 in this cell and the number 2 in this cell, yes, we would meet the rule that this black circle separates two numbers that differ by a factor of 2. However, we do have another white circle on top of the number 1, which means that the number in this cell must differ in magnitude by 1 compared to this cell. Now, the only number we can put here is 2. However, this would break the rules of classic Sudoku, because each column must have only one instance of each number from 1 to 6. So since the number 2 appears multiple times in this fourth column, this configuration would be incorrect. So by deduction, we know that we must place the number 2 here and the number 1 here. Now we are left to place the 4 and the 5. If we place the 5 on the left and the 4 on the right, well, then the rule number 3 would be broken because numbers 6 and 5 differ by a magnitude of 1. However, there is no white circle between them. So we must place the number 4 here and the number 5 here. And now you can see between numbers 1 and 4, 4 and 6, and 3 and 5, rule number 3 still holds. Alright, now let's move on to block number 5. Due to this black circle, we know that the number 2 must be placed here. Now, the cell above it must contain a number consecutive to 4, but we know it must be number 5 due to the number 3 already in the 5th row. Now, if we fill out this 5th row with the missing number, we can place the 1 here. And now the only numbers that are missing from the 5th block are the numbers 3 and 6. We know that we cannot place the number 3 here because this would break rule 3. There are no circles here. So we must place the 3 here and the 6 here. And now just to check, we know that between numbers 1 and 3, 4 and 6, 6 and 2, there are no circles, which means that rule number 3 is met. Now let's see where we can go from here. Let's take a look at the second column. We see that the second column is missing the numbers 1, 2, and 5. So these two cells must contain numbers that are consecutive to 3 and then consecutive to 4. So we cannot place the 1 in either. So the 1 must go here. Now since 5 isn't consecutive to 3, we cannot place the 5 in this cell. So we know that the 5 goes in this cell and the last number 2 goes in this cell. If we continue with block 3, we know that this top left cell must differ from 2 by a factor of 2. Now we have two choices. We can put either a 1 or a 4. But we know that the answer is 4 because of the number 1 already in the first column. Now, beside this number 5, we must place a number that is consecutive to 5. The only choices we have were 4 and 6, but since we already put the number 4 in this cell, we know that the number 6 must go here. And now just to check, we know that we aren't breaking rule number 3 between 4 and 6 and 1. Now the number that is consecutive to 2 must be placed here. So we have the options between 3 and 1. But which one should go where? If we were to place the number 1 here, we know for certain that the number 2 must be placed in this cell due to this black circle. So this would break the rules of classic Sudoku once again, because there are 2 instances of the number 2 in the 3rd row. This tells us that the number 1 must be placed here and the number 3 here. Let's move on to block 4. So now we know that the cell here must contain 6 due to this black circle. And once again, this black circle tells us that this cell must contain a 3. The only numbers that are consecutive to 3 are 4 and 2. However, due to the 4 in the 5th column, we must put the number 2 here. And the number 5 must go here because the only number available to us that is consecutive to 6 is 5. And once again, we can check that the numbers 2 and 5 still maintain rule number 3. If we move on to this bottom right cell here, we can place either the numbers 1 or 4 here. However, due to the number 1 already in the 4th row, we must place the number 4 here. And we can see that this white circle condition is met between 4 and 3. And finally, the last number missing in the 4th block is a 1, which is also the last number missing in the 3rd row. So as you can see, as we progress, the puzzles become easier and easier to solve. Okay, let's move to block 1 now. We see that the number 2 must be placed here due to this black circle. And then the only number that is missing from the first column is the number 5. Once again, rule 3 is met between 5 and 1 and 5 and 2, and between 1 and 3. So the two remaining numbers of this block are 4 and 6. However, due to these white circles here, we must know that the number 4 must be placed here, since 6 is not consecutive to 3, which tells us that the number 6 must go here. Now for this cell, we can place either the numbers 3 or 5, but due to the number 3 already in the second row, we know that the 5 must go here. And the last number in this second row is the number 6, which we can fill in. Once again, rule number 3 is not broken between 5 and 1, and 1 and 6. Finally, if we take a look at the last 3 columns here, we can fill in the remaining numbers. So the 4th column is missing the number 4, the 5th column is missing the number 3, and the 6th column is missing the number 2. And we also, of course, want to check that all the rules are met here. So number 4 is consecutive to 5, and number 4 is also consecutive to 3, which is consecutive to 2. And again, rule 3 is not broken between 1 and 3, and 2 and 6. And there we go, we have completed the entire puzzle. As always, the solutions are in the back of your workbook, but make sure you try the puzzle yourself first. I hope that helped. If you have any questions, just leave them in the comments below.